These radio waves are a portion of the greatest blasts on the planet. When we gaze toward the sun, we know about how much power and energy it conveys into the universe. There isn't a lot that could be preferable over our sun. Still, past our star is Betelgeuse, a red, very massive star that is so immense it makes even the most powerful solar monsters look small. Betelgeuse is a star that is hard to make sense of due to its enormous width, sporadic throbs, and eccentric conduct. Researchers are astounded by its power and potential. Yet, while they were studying this wonderful star, they found something unnerving. We're going to discuss what the James Webb Telescope found and how it could change everything. Betelgeuse should be visible in the sky if you gaze toward the night in the northern half of the globe during the winter. This is the sort of thing that most people don't know. It's not difficult to track down. Take a gander at the constellation Orion, and you'll see it as the orange-red star in the upper left corner of the rectangular-shaped constellation. It's easy to find because it's one of the biggest and brightest stars overhead. However, if you've paid attention, you know that the star doesn't stay in the same spot. It's one of the brightest stars when it's at its peak. However, sometimes it dims a bit. There's more to it than that. You see, from here, it seems like just another star, but it's not. It's over 640 light-years away. That may not seem like a long way at first, but it's actually quite far. Regardless of whether you could move faster than light, which we can't do, it would still take you over 640 years to get to Betelgeuse. Even our fastest spaceships would take more than 12 million years to arrive, which is longer than the history of all human culture on Earth. Moving farther away doesn't always change the light, but people consider Betelgeuse a beating red supergiant, which would mean this is a massive star that gets bigger and smaller. When it does, the sky can get brighter or darker. The changes in brightness can last for a long time, from a couple of days to a few hundred days. Furthermore, to make things much more odd, Betelgeuse's brightness can go from nearly minus 0.5 to plus 0, which is a pretty wide range. Among these changes, the shortest lasted 185 days, and the longest lasted 2,335 days. Betelgeuse can get very faint at times. Another name for this is V-band magnitude. In February 2021, a value of plus 1.614 was recorded as the lowest V-band magnitude in some time. It's not as bright as what we typically see from Betelgeuse, but it's still quite bright. It's known for more than just being bright, though. Betelgeuse is a radiant red star because its surface is very cool. Its temperature is only 3,500 Kelvin, which is much lower than the Sun's temperature of 5,500 Kelvin. Since it is cooler than the Sun, Betelgeuse emits significantly less energy per unit of surface area. For this reason, even though it is one of the biggest stars we know about, it looks much fainter. It's like a big individual who doesn't need to show off their size to feel significant. Just because Betelgeuse appears calm doesn't mean it's not a very massive star. It's multiple times heavier than our Sun. That is one reason why people study the star so much. Betelgeuse has been a brilliant star in the night sky for a very long time. The ancient Greek astronomer Timon was the first person to name it. In Arabic, it is known as the armpit of Orion. When it was first named, there wasn't much known about it, but now that telescopes are more common, researchers can study this event in more depth. By checking the light that Betelgeuse emits, researchers have learned a lot about it, like how big it is, how hot it is, and what lies beneath its surface. The Hubble Space Telescope has taken clear photos of the outer layer of Betelgeuse that show complex patterns of gas and dust. Scientists have been able to make models of the star's behavior and estimate how it will change in the future based on these discoveries. The Atacama Large Millimeter/Submillimeter Array, ALMA, telescope in Chile has also been used to study Betelgeuse. ALMA has taken very clear photos of the outer layer of Betelgeuse, which show us new things about its structure and how it behaves. One of the most exciting things that ALMA has shown us is that stars have huge plumes of gas rising from their surfaces. This cloud, which is believed to be caused by Betelgeuse's heartbeats, could help explain why the star behaves oddly and changes all the time. An interaction called convection makes Betelgeuse move this way and that. Hot gas rises and cooler gas falls. This movement causes disturbances that travel through the star's atmosphere, making it grow and shrink. With the Hubble Space Telescope, we can see the outer layer of Betelgeuse in great detail. The gas and dust are organized in extremely perplexing plans. Scientists have had the option to make models of the star's behavior. Based on these discoveries, they have been able to predict how it could act in the future. There are also dark spots on the surface of Betelgeuse. These are star spots, magnetic spots, or areas on the star's surface where the magnetic field is exceptionally strong. These regions are cooler than the gas around them because the magnetic field prevents hot gas from moving from inside the star to the surface. This cools the gas and makes the spots look darker than the gas around them. People believe that the magnetic field on Betelgeuse is a couple of times stronger than the field on the Sun. Gas on the star's surface gets trapped in loops or arches due to the strong magnetic field. This creates regions of intense magnetic activity that can be seen as dark spots. Alongside Betelgeuse, many other stars, including our Sun, have what are called star spots. However, the star spots on Betelgeuse are extremely interesting because they are larger and more numerous than on the Sun. Sometimes, the spots on Betelgeuse are as large as Earth and cover up to 20% of the star's surface. Additionally, star spots can change the brightness of a star and cause it to shine at different times. This is because the spots are cooler than the gas around them, so they emit less light. The spots move in and out of view as the star rotates, which changes how bright the star is. For Betelgeuse, the star's throbs also cause changes in its brightness, since the spots can move in and out of view, adding to the star's variability. The most interesting thing is that Betelgeuse isn't exactly unique, as some stars are similar to it, but not all of them are the same. Still, they are all very intriguing. Antares, a bright supergiant in the constellation Scorpius, is similar to Betelgeuse. Like Betelgeuse, Antares is a variable star, which means that its brightness changes over time. Antares is also exceptionally large, around 12 times greater than the Sun, and its width is multiple times greater than the Sun's. This makes it pretty clear that Antares is not a contracting violet. People often refer to Musca, also called the Garnet Star and found in the constellation Cepheus, which resembles Betelgeuse with a radius about multiple times greater than the Sun. Musca is perhaps one of the largest stars we know of. Musca is a variable star, just like Betelgeuse and Antares. It is also one of the largest red supergiants in the Milky Way. Despite Betelgeuse being unique, these stars are fascinating in their own ways. A few things that make each star special are its properties and attributes. It's interesting to learn about all of them and see how they change. We'll use our Sun as an example to show the difference, since we all know a lot about it. Even though Betelgeuse and Antares are red supergiant stars, they are not the same. Each has its own traits that make it stand out. One major difference between the three stars is how large they are. For example, Betelgeuse is multiple times the size of the Sun, and Antares is around 700 times the size of the Sun. Another star, Musca, is significantly larger. Its diameter is about multiple times that of the Sun. The brightness of the three stars is another factor that makes them different. Betelgeuse has an apparent magnitude that ranges from 0.0 to 1.3, making it one of the brightest stars in the sky at night. Antares also varies in brightness, but sometimes it is a bit brighter. However, Musca is much brighter, with an apparent magnitude that changes from -3.4 to -5.1. These stars are also not all the same mass. Based on estimates, Betelgeuse is multiple times as heavy as the Sun, and Antares is also multiple times as heavy. This means that the two stars are about the same size and brightness. Musca, on the other hand, is much heavier than the Sun. Its mass is believed to be multiple times that of the Sun. Finally, each star has its own set of qualities and ways of acting. As we previously discussed, Betelgeuse is known for its throbs, which makes it more brilliant and hazier. After some time, however, Betelgeuse is ringed by a colossal haze of gas and dust, which could help make sense of why it acts in an unusual manner. Despite the fact that it's more brilliant than Betelgeuse, it doesn't look as bright because of the clouds and dust around it. While BJ is known for being entirely unstable, Betelgeuse is known for being exceptionally brilliant, making it one of the brightest stars in the sky. And despite the fact that we've already discussed the star's throbbing tone and general conduct, they all feature exactly the same thing. A supernova is going to occur, and it could happen very soon. A supernova sounds lovely the first time you catch wind of it, and in a manner, it is. It's frightening when you truly start to understand it, but toward the end of their lifetimes, some kinds of stars detonate in supernovae, which are extremely powerful explosions. A lot of energy is released by these blasts, making some of the brightest and most energetic events in the universe. Type 1 and Type 2 are the two main kinds of supernovae. When a white dwarf star, which is the dense remnant of a low-mass star, takes in matter from a companion star until it hits a specific mass, a Type 1 supernova occurs. This starts an atomic fusion process that goes haywire and causes the star to explode. There isn't much time left for the star, and when it blows up, it causes a lot of damage, though nothing compared to Type 2 supernovae. Type 2 supernovae occur when a star with a lot of mass runs out of fuel and can't continue the atomic cycles that maintain a certain level of control. As a result, the star implodes in on itself and then detonates in a tremendous manner. A huge amount of energy is released as light, heat, and radiation. When a supernova happens, everything in its way is cleared away. It is possible for the blast to be bright enough to shine brighter than the entire galaxy the star is in. However, this brilliance will only last for a short time, typically for a few weeks or perhaps a few months. It also creates a lot of heavy elements like iron, nickel, and gold when a supernova goes off. Nucleosynthesis is the process that forms these elements, occurring in the high heat and pressure of the explosion. After being ejected, these elements are sent into space, where they can be used to form new stars and planets. It's kind of like a star dying to make room for new ones. We all know that it takes a lot to make a star, so this isn't just about abandoning things. The shockwave from a supernova can actually cause new stars to form. It can also compress nearby clouds of gas and dust enough to make planets form. In cosmology, supernovae are also useful because they help us figure out the distance to galaxies that we otherwise couldn't measure. Since supernovae always have the same brightest point, researchers use them as standard candles to determine how far away things are. Also, supernovae are quite beautiful. The growing haze of gas and dust created by the explosion can take on various colors and shapes depending on the type of supernova and its location. But truly, they're very dangerous, even though they look beautiful. Radiation with a lot of energy is one of the main dangers of supernovae. There is an explosion of gamma-ray radiation that comes from a supernova, which can be thousands of times stronger than the energy our sun radiates in its entire lifetime. Because it is so strong, this radiation can kill all living things on Earth. It can damage DNA and other organic molecules, destroying the building blocks of life as we know it. It is also possible for a huge shockwave to occur when the supernova explodes. It sends out a shockwave that can travel through space at very high speeds and may hit other objects in its path. The forces that make it possible for new stars and planets to form can also do the opposite. For example, if a supernova happened nearby, the shockwave could damage Earth's atmosphere considerably and even wipe out entire species. Various experts have different ideas about when Betelgeuse could go supernova. Some say it may be millions of years away or about to happen. But the amount of dimming suggests that this celestial event might be much closer than we'd like. People think that Earth is a safe distance from the star, but things can get really crazy when things like this happen. Could the Earth be wiped out by the Betelgeuse supernova? Please answer the question and share your thoughts in the space below. If you like this video, please give it a thumbs up. See you in the next one.